Live from New York, it's Ask a Bunch of Engineers and More.
Hey everybody, and welcome to another episode of Ask Engineers. Today we actually have a plethora of a multitude of engineers here at the Adafruit factory, which is where we're broadcasting from. We're in downtown Manhattan at the Adafruit factory, where we design and manufacture and ship and support all the awesome Adafruit electronics products and projects and tutorials. Yeah. And in fact, today we even have some of the people who have been instrumental in creating those products, projects, and tutorials. So it's going to be an awesome show with all these special guests. So let's get it kicking.
All right, first
Mr. Legata, what's going on?
Well, the code is NY Maker Faire because a lot of folks are in town this week for Maker Faire. The 10% off all the way up until 11:59 p.m. Eastern time tonight. Everything except for gift certificates and software and AdaBox. I think we're out of AdaBoxes for this round, but you can still try. Not for the code, but for getting an AdaBox. Show and Tell, Lady Ada will talk about the folks who showed and shared the projects from around the world. Back at the mailbox, gonna stop by, read some letters from y'all. Help wanted, the Adafruit Jobs Board. If you wanted to work on saws, we will tell you about that. Time travel. Yeah, I know, right? Time travel, we'll look back at the world of hackers, makers, artists, engineers, and more. Some made in NYC, some footage and more from the Adafruit factory. 3D printing, new products. We're gonna answer your question. We'll have a top secret thing. Ooh, we'll have a trivia question, all that and more on Ask an Engineer. Okay, it's action packed.
Okay.
All right, so before we get started, pay some bills and more, show and tell, and then we'll introduce these fine folks.
Yeah, sure.
Okay, all right.
Sounds like a plan.
Okay, first up, big news. Thank you, everyone. 30 million thank yous. We're up to 30 million views for the folks watching. You were part of it. So congratulations. Thank you. That was on YouTube. We just hit that. Yay! So many of you sitting here were responsible for many of those views. We're still doing free UPS ground for $200 or more in continental USA. On checkout, you'll see that as an option. Same day if you're in Manhattan, 11 a.m. or sooner. You'll see that if you're in a zip code that we have same day for. Lady Ada, show and tell happened.
It did.
We do this every week at 7:30.
It was really cool.
What did folks show and share on the show and tell this week?
I'd love to tell you about it. I will go through my list. Okay, so start off with Noe, who's representing for Noe and Pedro. They're both going to also be at Maker Faire New York, so that's exciting. But before they finished packing up, Noe had a cool icosahedron mace. He's been playing around with icosahedrons, making glowing ones, and then he decided, you know what, this would make a cool morning star weapon. So he made a cyber night weapon. I don't know, it's neat. It's fun to swing around. Check out the video and the tutorial. It's live now, and they'll be talking about it tomorrow on 3D Hangouts every Thursday at about 3 p.m.-ish. And then Sophie came in, and she made a cool outfit for Seattle Maker Faire. It's this leather harness with LED strips. It's like Cyber Barbarella outfit. So check it out. She worked with Kim, her partner in crime, and they used a Trinket Pro, I think, and then they had a Perma Proto, and they had the NeoPixel strips, of course. And she actually ended up having a lot more wiring than expected. I think it was the silicone LED silicone wires, but she liked it because it looked like veins a little bit. So she had this wiring harness, and then on on the back she had this cool, chunky 3D printed case, and it was pretty awesome looking. So if you saw her at this Maker Faire, or if you see her at a future Maker Faire, be like, I saw you on Show and Tell. Sean is at a Nova Scotia Maker Faire, Makerspace, and they have a pinball machine they made, and they used 12-pixel NeoPixel rings for the bumpers. And so instead of just hitting the bumpers and you don't know how many times you have to hit them to get the next score point or complete the quest or whatever it is in the pinball game, it'll actually light up each of the NeoPixel LEDs, so you know how many more times you have to thwack each bumper. So that's really neat, and kind of neat. It was a plywood-made pinball machine, so they're probably going to be showing that off at some place. But if you're in Nova Scotia, I guess check that out. Also, maybe have some salmon. Okay, Peter is from the Fat Cat Makerspace in West Village, which is really nearby here, and they had a 6-person project where they made a ping pong ball shooting gallery, just like the galleries that you see on the streets here when you go to the street fairs. But this one had really cool Space Invaders, and it was all makery, and it had a Raspberry Pi and LEDs and trinkets and stuff. And they're hopefully going to be showing it at New York Maker Faire as well, if it finishes and it works by Saturday. So Godspeed to them, and check that out at the Fat Cat Makerspace, a really cool looking spot. Scott came in, and he's a DevOps engineer. He's in charge of a bunch of servers. And he's tired of looking at a screen. So boring. Why look at a screen when you can look at the skull of ops?
Yay.
It's a skull. It's a skull with LEDs all around it and the eyeballs. And when they're green, it means his websites are up. And when they're yellow or red, it means Radiskull is coming to get him, and he should check out his web servers and why they're down.
No devil doll.
And Devil Doll. You can be the Devil Doll.
Radiskull.
Radiskull. Okay, so that's for people who are over 30.
Joe Spark stuff. Wow. Vintage.
Yeah.
Macromedia Flash. These are just words.
Radiskull, I want some coffee.
I know.
I think that was the first one. Okay, so it's time to kick it.
Yeah.
With the Skull of Ops. It's a Skull of Ops by Scott. So thanks for that. And I asked him, was he going to make one for each person on his team? And he said he actually did. He made a little one for this person on his team.
Yeah.
And they have to plug it in and keep it with them at all times.
Yeah.
So this is actually like the bastard operator from hell. This is actually the person. He has these skulls. A very happy looking skull. And it was in a glass case. It's like the coolest thing I've ever seen. We need one here. And then Lon is working on a Halloween pirate outfit with some foam daggers and sabers, very piratey. And then Aiden is experimenting with NinjaFlex mesostructures that are 3D printed and have different properties. And I don't remember the name of the person, and I forgot to write it down, who on Thingiverse has been working on these sort of elastomer, like 3D printed, like, he calls them mesostructures, or structures that are like fractally, so they can stretch and pull, but they don't compress very well in one direction. So kind of interesting, maybe used for insulation or for like bumper, you said like bumper cars or like clothing or shoes or something. Could be interesting to see these unique materials. But I like how he's always doing something different.
Yeah.
He's really taking the materials to a different place.
And did you mention he'll be at Maker Faire doing
He's
a couple
also going to be
talks
Maker
and
Faire,
showing
and he's going to have these cool
instructions?
things.
So go squeeze them.
Go squeeze them, and only in one direction.
Yeah.
And what I like is he's also, you can tell he's a scientist, because he's like, I made this thing and it's really cool, but I don't know what the application is, but there's probably one somewhere. And that's exactly the kind of philosophy you have to have as a scientist. Like,
And it's highly compliant and conforms to surfaces.
Exactly. But like, what is it good for? I don't know. But sometimes you find out later it is good for something, and that isn't something, that's what science is all about. They create stuff, and then years later it's like, whoa, turns out that's exactly the material I need for my project. So he has a good future as a scientist.
Okay. All participants on the show and tell get an As Seen on the Show and Tell sticker. If you're on the show and tell, email support@adafruit.com and we'll send you one. This is part of the Adafruit Live series. And speaking of, we have many people who are on many of our videos. Tony D is here this week. Tony released a video during the week, MicroPython and NeoPixel demo scene plasma with Tony D. Tony, introduce yourself and what have you been up to?
And I forgot, we had one more person that we had him on the show and tell, and I forgot to write it down.
He's right here.
But you're going to talk about, maybe you could talk about what you talked about in the show
All
and
right,
tell.
2 for 1 now.
Thank you.
Yeah, so it's Tony D, and you might have seen me on Adafruit's YouTube and Twitch channel. So I do Desk of Tony D, or Watch Tony D's Desk, rather. And so this week, or last week, rather, I did a really fun one where I didn't have like a big idea in mind. I just wanted to kind of turn on the camera and play around. So I implemented old school demo scene effects, something called Plasma. And if you don't even know what the demo scene is, go watch the video because I talk a little bit about it, but really cool computer generated artwork. And so what you're seeing in the video is just like some noise, multicolored kind of things. It's a little hard on, that's a 40 pixel grid, so you don't really see the full kind of magnitude of it. But this is all in MicroPython, which is the cool thing that I wanted to show, is that it's high level Python code, it's pretty easy to understand, and it's all just sine and cosine. So if you know 7th grade math, you'll actually be able to understand how this works. So check that out for that video. And then show and tell, I actually showed off the same pixel grid, but with a different processor that we'll talk a little bit
So
more
what
about
processor
later.
was this?
This was the ESP8266, so the Wi-Fi microcontroller, runs MicroPython really well, and it's got NeoPixel support. And then on show and tell, I showed off the same little board, but with the SAMD21, which is like the Feather M0 processor, and that was something that I just created the NeoPixel support for. So we just ported over our Arduino library. So we'll hopefully soon, maybe this week, maybe Friday, might have a special Watch Tony D's Desk at Adafruit Studio. I don't know, we'll see if the Wirecast gods are with us, but maybe I'll hack around with some more NeoPixel stuff, maybe demo scene stuff, maybe like a scroller, you know, the up and down kind of text. That could be a fun one to do. So
Snake.
yeah, exactly.
It's tough with only 40 pixels.
Right, Starfield, maybe something like that. So.
All right. And for folks who want to watch either your MicroPython series or the Desk of Tony D, we have playlists on
Yeah, check it out.
YouTube.com/Adafruit for all this stuff.
Right, there's about 16, 17 videos, something like that. So,
Yeah.
and if you don't know what MicroPython is, check out the What is MicroPython video and guide. So that's where I go into detail, like, what is this thing? It's Python on a microcontroller, so
Yeah.
cool thing.
Okay. All right. Well, next up, John Park. So it was difficult to figure out what exactly we would introduce you with, and some people
Boy.
knew you, knew you from like Make Television. Maybe some people know you from your animation career and more. But a lot of people know you from this giant Arduino and that mustache.
Yeah,
So-
they're notable both.
Yeah.
The mustache and the
so
Arduino.
who are you and what you do?
Yeah,
and
hi,
what you
I'm
up
John
to?
Park, and yes, you may know me from Make Television. You may know me from, I've worked in animation for a couple decades or more, which makes me feel a little old, especially sitting next to these fellas. But I have been working with Adafruit to build projects for the last couple of months and release videos and guides and get to use all the great stuff that I love so much from Adafruit. And yeah, that was a giant Arduino, fully functioning Arduino I built a few years ago. Designed it and mostly laser cut parts, but it's got a actual Arduino Uno that is patched out to giant banana plug ports for the header pins, so you can plug stuff into it. And I made gigantic resistors, and I used Atari 2600 paddles as potentiometers to demo stuff, and used some big 10mm LEDs to show people how an Arduino works without having to talk about a thing that they can't really see if you're teaching a class, for example. And so I've had a few projects actually where I like to make huge versions of things. I've made some gigantic working handcuffs to teach how to escape handcuffs, and maybe I'll do some more gigantic projects in the future, but it's something I like to do.
Speaking of, there's going to be a gigantic circuit playground at
cool.
Maker Faire, from what I understand.
Very, very
and
cool.
you've been doing videos about circuit playground.
Nice
so-
segue. I love
Yeah.
Circuit Playground. I have started doing a few projects. I did the password vault with the Circuit Playground, which is a little device you can carry actual passwords on and plug into a computer and fire off passwords into your computer without having to remember them, so they can be nice, long, secure ones. And I also made the class scheduler, and then a project that I have here with me tonight is the PZ1 Circuit Playground Pizza Box DJ
Yeah.
controller, and I'm going to demo that a little bit later.
Yeah, stick around,
and you get
folks.
to say, go to the clip, but it's a video. You
I
get
will say,
you
go
get
to the clip.
Yeah, you could do that. By the way, this is probably not the size of that circuit playground you're going to see.
In
It's really
proportion
big.
to us, it's
Yeah.
going to roll
Yeah.
through Maker Faire crushing.
It's
All right,
a Katamari
we are
Damacy.
rolling the clip. This is the clip rolling.
Roll it.
Hi, this is John Park for Adafruit. Today I'm going to talk to you about the Circuit Playground PZ1, which is a pizza box DJ controller. So what is a DJ controller? This is a MIDI controller used to control DJ software on your laptop. Now, laptop DJ software can be controlled from the keyboard. For example, now, the problem with this is that you've got a lot of key commands to memorize, and it's not super ergonomic. Now, you don't have to use the keyboard, of course. There are some great solutions out there, such as MIDI controllers, like this little mini Unz I built. It uses lighted pads, and you can assign these buttons to different controls in the software. Or you can get turntable-like controllers. Now, this one's actually from a video game console, but it's pretty similar to ones that you'll see out there that are designed expressly to control your DJ software. So what I decided to do was check and see if I could create a MIDI controller using the Circuit Playground. What I have here is a Circuit Playground, and I've uploaded some code on it that both sends MIDI signals when I touch the various buttons and pads, and it's also sound reactive, so you can see the lights lighting up as the volume changes in the room. With this controller, I've actually got some alligator clips and pennies connected to them so that I can use the capacitive touch sensors. For example, now this is pretty cool, but one problem with it is that it's a little hard to keep track of which controls do what, and it's also sort of a weird floppy interface to take to the club. So what I decided to try next was a pizza box, and I used some conductive paint to create little traces. And when I touched those traces, it would send the signals via MIDI over to the laptop. Now, this is pretty cool, but I didn't love my freehand painting attempt. So what I'd like to do next is show you how to create your own conductive ink circuit using a stencil and conductive paint. I decided to create one on the computer using CAD software and then cut it out on laser cutter. So I started out with this 12 by 12 inch piece of 7mm Mylar, and after running it through the laser cutter, we get this beauty. Now it's time to paint this stencil onto my pizza box. I'm going to start off by spraying the back of it with a little bit of spray adhesive so that the stencil sticks nicely to the cardboard. And this spray adhesive helps with some of the very small pieces so that they don't lift up or get paint underneath them, which could short a circuit. You can see on this one that I sprayed earlier, in some places I broke what's going to be my contacts with little lines so that the stencil doesn't flop around too much, and then those lines can be painted over after the stencil has been transferred. Looks good. There is our Circuit Playground PZ1. Now what we'll do is take a small brush and fill in any of these little breaks that were there to help the stencil stay in place. Just paint over those breaks. Let's take a look at the functions of the PZ1. We've got Q, start and stop, for the left deck. We've got scratching for the right deck. The buttons on the Circuit Playground will play deck A and start effects on deck A. And then I've got trash for the hot cue, so I can start new cues later in the track as it plays. And I've got a play for deck B for when I'm not scratching. And then these two I've got assigned to triggers so they can loop sound effects, but you can reassign them to anything you want using the MIDI controller software. Now I'm going to attach my Circuit Playground with a little bit of conductive paint. You should be careful when you do this not to blob on too much, because then it can fill in the gaps and our traces will get connected or short-circuited. I'm just going to put a little blob of paint in the center. The paint has dried on the Circuit Playground, and now we're ready to fire it up. I'm going to plug this in. And I've set up the MIDI controls to work with these surfaces, so let's give it a spin. That is the Adafruit Circuit Playground PZ1 Pizza Box DJ controller. Now I got a delivery. See ya.
All right, so that was nice. I got to say, go to the clip.
Yeah, that was fun, huh?
Yeah.
Go to the clip, like
Good job
pros.
there.
All right, and next up,
Enjoyed.
in person, Scott, you're here.
Hi.
You're normally on the other side of the camera, show and tell.
Yeah, so usually I do show and tell. Let me give you a little background. So I'm Scott. I've been on show and tell. Before that, I was doing a company, I'm doing a company called Chickadee Tech on the side now. I now work for Adafruit mostly, which is awesome. And before that, I was at Google on Google Maps. So I'm a software engineer by training. And I posted on the jobs board.
Yeah.
I can plug that too. And then I
It worked out for you.
And then I went on show and tell, and I was like, "Hey guys,
Got us all plugs rolled into one.
I'm on the show and
That's where we met
I'm on the
Tony as
jobs
well.
board.
So it all worked out.
Got an email, and basically I've been brought in to do MicroPython work, which is awesome because it's open source, and it has a ton of potential to make microcontrollers even more accessible than they already are. So yeah, I'm super excited about it. Python's a great language to learn. And so what I'm doing is I'm taking all of the awesome work that the MicroPython project has done in the last 3 years.
Yeah,
Like,
nice.
I don't mean to say that like this is brand new.
A nice graphic.
Yeah, I guess I could talk about
This
my stuff
snake.
too.
yeah.
But yeah, so MicroPython's been around 3 years, and the work that I'm doing is basically making it run on the Atmel SAMD21, which is all of the M0s that you see from Adafruit is that chip. So yeah, that's the work I'm doing for Adafruit, and I don't know, should I go back?
Yeah,
and
well, I just want to
talk
ask you.
about
Well,
the previous stuff I've
well, a
done?
couple questions. So you were like a mini Adafruit, like you did manufacturing.
I tried.
Yeah,
And I'm trying.
Yeah, and you designed the hardware, you had
Yeah.
the software, and where would people see some of the things that you made? Like, where would they be using it?
Right. So the animation that you're seeing here is it's called Polystack, and that's kind of the generic brand name for this system. So the idea is that you can have a power board on the bottom, a control board in the middle, and then a bunch of expansion boards that can use tons of the I/O from the microcontroller. And the use case that I had as the first thing was for flight control microcontrollers for quadcopters in particular. So they run the STM32 line of chips, and it's this open source software called Betaflight that it runs. So I had dug into like some HAL stuff and some microcontroller stuff there. So it segued really nicely into the port of MicroPython also. So yeah, the website is chickadee.tech. The store's up there if people are interested, and especially if you're into quadcopters and stuff, this is going to run your latest Betaflight code. I'm still supporting it and everything, even though I'm now doing a lot of work for Adafruit.
And thank you so much for doing open source hardware. Like, we never even talked about this. You just did it, and that was one of the ways that we're like, this is an interesting person doing interesting things. They're showing their work. You came on the show and tell you did live factory stuff, and then from the start, you're like, I'm doing open source. Why did you make that decision? Because that's unusual. Usually people are like, oh, open source it later when it's successful.
Yeah, so
that never happens.
I should kind of be fair to myself. I was actually closed source as I did a lot of the initial stuff, but I always intended on open sourcing it. So by the time that I had actually launched and selling on the site, everything was available.
Oh, great.
I know some people do that where they like start to sell it and say it's open source, but they haven't released it yet. I made sure and didn't do that.
Yeah, we're like a Kickstarter. If we only get enough money, it's like
Right.
hostage source. I think
Right.
that's like I'm gonna totally write that.
coin
Like,
that?
it's hostage source, but it's like, oh, if we make enough money, then we'll give it away.
Right. I think for me, I come from the software world, and I've learned a ton from open source software. And then I learned a ton, like I'd never done hardware before. So I also learned a ton by some Adafruit designs, the test jig series. I told you this before, Lamore. The test jig series, if you're doing test jigs, which I did a test jig for this stuff, it was just super, super, super useful. And I want to give back. For me, it was not just about making, like starting a company and making money. It was also about building my resume, building my skill set out. Because I take pride in being kind of an extreme generalist.
Yeah.
Where I can go all the way from the hardware side. Like full stack is a term that people use, but that's
full
only
sta-
software.
full
Yeah,
stack-
but they don't even know C. Or,
Full stack means
they stop at like JavaScript.
I will modify Indicia to ship packages. Like that's full stack now in hardware. Like I'll go all the way to shipping.
Right. So yeah, I don't know, but I feel like I'm like completely full stack.
I will deliver it myself.
Yeah.
That's full stack.
Yeah.
I'll be at your house with a box.
Yeah, so and I also learned to appreciate the business side of things as well. So I did all of the engineering. We went through and I did a production run, a self-funded production run, using a startup called Macrofab. I'll plug them too. I did the show and tell from their factory.
that was so cool.
They were really cool, and they're great for prototyping. So like you can basically pay retail for one of these boards and get it fully assembled for them for the cost of retail. And they'll just they'll order a single unit of like one of these STM32 chips to put it on your prototype for you.
That's right.
And then of course as you order more of them, you can see how the price goes down.
No,
So-
you can even like see it.
yeah.
That's cool.
It's all it's all self-service. I had somebody just contact me recently saying like, hey, why didn't you go with this other company? Why did you use Macrofab? And I looked at their site and I said, I can't just log in. Like,
Yeah.
I have to request access.
Yeah.
And like with
Yeah,
Macrofab.
you get a quote, and who knows, and they call you on the phone.
Now you're a
Yeah.
pre-qualified sales lead.
Yeah, yeah.
And they're like, how much are you willing to spend? And you're like, that's not the thing.
Yeah. I had a little bit of a discussion like that with Macrofab.
Yeah.
After I kind of went off their main course because I got custom PCB colors.
Yeah.
Which meant that I had to fund like a full panel for myself.
Mm-hmm.
So one of the ways they do inexpensive prototypes is they panelize it just like Oshpark does.
Okay.
But because I wanted the like black FR4 with the transparent solder mask, I had to end up having some discussions with them about like what volume I was doing and
Yeah.
whether all the manual work they were doing for me was worth it. But
Okay.
they're great people. I had a great time talking with them, and I learned a lot about hardware. I learned like how hard business is,
Yeah.
and I was so, after I launched, I was like, okay, this is not gonna like pay me enough to keep going.
It takes about 10 years.
Yeah, I was doing it.
Speaking of, the code is in 1 Maker for 10% off the Adafruit store all the way up till 11:59 p.m. Okay. Back.
All right, go back.
Yeah.
Bye.
So after a month, I was like, I need
Yeah.
a job. So that's when I posted on the
But
job
you're still doing it. It's just like
Yeah,
less,
it's still live.
It's like part-time.
I intend on supporting everything. We may do one board, a production run of one board extra, but for all of the other boards, I still have plenty.
Yeah.
But yeah, I want to keep doing it.
Okay. All right. Well, thank you so much. I remember when we were doing the tester series, and you and I think 2 other people who did hardware, they're like, this is so useful. It was just like,
Yeah.
finally. Like,
Is this the one with the open OCD or the one with the clamps?
So the OpenOCD one came a little late.
Oh, sorry. It
I
always
would
does, doesn't
we
it?
will go back in time.
I would
and
recommend
test
it
videos,
to
yeah.
anybody who's still doing that. So my test jig did do the flashing. So it would like flash a test program and then flash the beta
Yeah.
flight on it. And because I'm doing STM32 and the discovery boards are really inexpensive.
Yeah, you just gank that.
I used a base board of that and then made basically a shield on top that
Yeah.
works
It's like
with all
us
of
using
them.
Raspberry
That's
Pis
what we
for
do. We use
stuff.
Raspberry Pis and Arduinos as the
Yep.
base because it's like I don't want to reprocess that whole part. All I do is make the tester that just brings
Yep.
out the pins to the board I'm testing on.
I know, I learned a lot.
Yeah, and I'm just like,
Okay.
Yeah.
Well, speaking
you
of
have multiple
MicroPython,
products?
because
For
we
sure.
have the 2 people that are at Adafruit driving a lot of the MicroPython stuff, I thought maybe, Tony, you could talk about, like, you were doing a lot of Arduino stuff and Pi stuff. What are the appealing things for you as a software engineer and also someone who teaches electronics? Like, what were the appealing things about MicroPython for you as the educator side,
Right,
too?
and just for some background, so MicroPython, micropython.org, you can check it out, and we've also done a whole bunch of videos like what it is. It's Python that runs on a microcontroller, and the really cool thing is because Python is a language that's easy for beginners to pick up, like the syntax is simpler, there's white space, which is sometimes a little easier, but just a little bit more accessible to beginners, and there's already a ton of stuff out there about how to learn Python, good beginner books. So that's one really nice thing for learning electronics, where if
Yeah.
you can use a language that's easy to learn and easy to be productive in, you'll have a lot more fun and do better with it. The other cool thing, though, is that MicroPython is interpreted. So that's in comparison to Arduino, where you have to have a compiler that turns the code into machine code that's then loaded onto the board. And that has some advantages. It's maybe fast in some cases, but some disadvantages too. You have to have this whole compiler tool chain. So when you download the Arduino IDE, they've done a ton of work to hide all that from you. But it's things that have to happen behind the scenes. There's a lot of moving parts. It's difficult to take that and make it work like on a Chromebook, for example, where you can't have native code like that running. So MicroPython is cool because with Python, you can connect to a Python terminal and run the Python code directly. So for a beginner, that's really cool because if you want to blink an LED, instead of like learning what a sketch is and defining the code for it and uploading it and getting it installed and all of that, you just connect your board, open up the serial terminal, LED.on, LED.off, run a little command, and you get instant feedback for it. So that's where I think you'll really see some cool stuff with MicroPython for beginners, that you can be more productive and you can just get started right away with it in comparison to other things like Arduino. But it's all trade-offs, so like we'll kind of see how everything works with it as we go forward. So it's a really cool, exciting project that we're really looking forward to.
All right, and Scott, I'll turn it over to you now. So you were working at Google doing maps. You did the bicycle routing stuff. So that's very different than
not the routing.
Yeah, or so. Yeah,
Part of it.
And that now you're trying to squeeze all of Python onto a tiny chip. Like,
Well, luckily somebody's done that for me.
Yeah.
I don't really have to worry about squeezing Python itself. Like the MicroPython people have done a good job.
Yeah.
But then what you've been hearing is like, oh, this doesn't work. Like
Yeah,
we need to import
getting it
this
all to-
module. Like we need to be able to do file system stuff. We need mass storage devices.
Like little details about like the underlying the hardware chip, like how to, you like spent time doing analog digital conversion. Like
Yeah.
for every microcontroller that uses MicroPython, somebody has to write that code
Yeah.
that takes the pretty, happy.
Is that somebody, Scott?
That's
In this case, that's somebody is
It's not somebody, it's Scott. Yeah.
Yeah, but just for the SAMD
Yeah.
one.
Yeah, I should say on GitHub I'm Tannewt,
Okay.
Tannewt. So if you see that, that's what's happening. That's
Okay.
me.
Gotcha.
In case people don't know that.
Okay, and we're almost ready to start having more people do stuff with what we're doing with MicroPython. So where would they go, and what would they do if they wanted to?
So check out on the Learn site, learn.adafruit.com/category/MicroPython.
Yeah, or you could just like hover over categories.
Exactly,
yeah.
or just type in the search MicroPython. You'll see there's about 12 or 13 guides and a whole bunch of videos. Start with the What is MicroPython guide if you don't know anything. So I give you all kinds of background info, links to more stuff. So start there. But we build up and say, here's how to do, like how to load it onto a board, like what boards support it, for example, and then more advanced stuff. So when you want to start talking to hardware, how do you control digital I/O, stuff like that. So check it out, learn.adafruit.com. Also micropython.org. That's kind of the main website. You can learn a little bit more about it there. So.
Okay, well, we'll answer a couple questions as we go. What's SAMD, since we keep mentioning it? Who wants to answer what SAMD
Okay,
is?
so, yeah, so SAMD, that's a chip, it's an Atmel chip, SAMD21, used in some boards like the Feather M0, Arduino 0, I think was kind of the original one. And so it's just it's a Cortex M0, which is like a fancier microprocessor. Think of it like an Arduino Uno with more memory, more speed, more capabilities, basically.
Yeah, could you run MicroPython on Uno?
Not necessarily, unfortunately, right? So
I don't. There's absolutely no chance. Sorry.
Yeah.
The answer is like a definite no. Nope. You need at least
very optimistic.
16K, at least 32-bit of addressing, at least 16K of RAM, at least 128K of flash. So the trade-off you get with the simplicity of an interpreted language is you need a lot more storage space. The Arduino Uno doesn't have that, but the SAMD21, which acts a lot like the Arduino Uno chip, has all that extra goodies in it that you end up spending in MicroPython, but you get this simplicity.
Yeah. Okay. All right. Well, thank you, folks, for the intros and more. We're going to continue on the show. Feel free to jump in as certain things come up. But now it's time to do the mailbag. Hi, unpack it, the mailbag. Letters. These are the emails that we read off at our all-company meeting, State of the Fruit. This one was sent in. This is not for me, even though it says Phil. While I'm here, could you please pass the word up the ladder that your support forum is the best I've ever encountered in my 30 years of technology development.
Oh, yeah.
So, yay, that's where we have all of the Adafruit engineers helping out customers and more. Okay, jobs.adafruit.com. Use that, Scott. This week, and it works. Yeah. This week, this is interesting. So we're starting to become like the maker matchmaker. Like if you want to find amazing folks in the world of microcontrollers, the companies are posting on jobs.adafruit.com, and people who know this stuff are posting there. So this one's cool. Do you want to be an STM32 embedded engineer at Stanley Black & Decker? You know, the one to make saws.
You bet.
Yeah, like that just sounds fun. So what they're looking for is an ARM Cortex M0, M3, M4 embedded designer with ST micros, familiarity with STM Cube hardware, abstraction layer, and design tools, C software implementations, parallel TFT displays, embedded USB hosts. Power tools are probably about to get really interesting. If you're Stanley, if you're Stanley's the competitor, like you're probably like, these things are gonna like tweet.
I just checked out the Shaper today, which is the CNC handheld router that
Yeah, that's where it's
carves
going.
for you, and you can understand why power tool companies are wanting to get engineers in there.
Yeah.
With some
Look, Python,
microcontrollers.
Java, C++,
this a full stack
VB,
router?
Delphi.
But the other kind of routers?
What Delphi? ARM DSP libraries.
Parallel TFT displays, I can do that.
Yeah.
Yeah.
So if you're an engineer and you want to work for Stanley Black & Decker, you can do it. It's in Maryland.
Don't go anywhere, Lady Ada.
It sounds
Yeah.
like they basically want to like install a full, like a basically MicroPython or a full RTOS onto
You're
these devices. But you're right. This is the future: is smart tools.
Yeah.
Because like, how many more like volts can you add? It's always like 18 volts, 24 volts. It's like you.
Yeah.
That's a lie.
It's never enough.
You know what they say, software is eating the world. There's those table saws that if it detects a human finger,
stop.
and there's always like a hot dog demo because like it's like, oh look, it looks like a finger, but that stops the saw, which is
They're
kind of neat.
fantastic.
Capacitive touch.
Have you ever? Did you ever use one of
I've
those?
used them a lot, but never cut myself.
Yeah, I never want to test it.
This is the problem. You're like, I wanted.
I think the inventor guy does. He, like,
No,
Really?
you can't do it.
I think he does.
The inventor of the solid ink printers that Xerox bought, he used to eat the ink to say how non-toxic it was. That's just another one.
Until
So I got acquired by Xerox.
Oh.
Like you can't do that on stage anymore now. So next up, time travel. News in the world of hackers, artists, engineers, pioneers, and more. This one's a little different. This is celebrating a special birthday. Happy 33 years old, GNU.
Yay, GNU.
Yeah, so Stallman announces the GNU project, a free Unix-like operating systems. Lady Ada, you're like a resident, super crusty open source person.
I have a ladyada@gnu.org email address.
Whoa, okay, see? I didn't know that. I always learn something new about you.
Yeah, I do.
Wow.
It still works, I think.
Okay.
Yeah.
So for the folks who don't even know what this is, they're like, oh, or maybe they're like, oh, I kind of heard about. There's always like this Linuxy thing. What is it?
Well, it's actually really cool. So, you know, when you run, like, you know, you have a Mac and you have the Finder, and the Finder is the thing that lets you, like, you know, locate files and stuff. There's like the thing that displays text and graphics on your computer, but all the other tools that you use with your Mac, like a web browser or like editing text or like anything other than just like the raw computer, that's like all the accessory tools that like basically GNU wrote for Linux. So
Okay.
like, you know, when people talk about Linux, there's the kernel, which is just the thing that basically gets the computer up and running, but you know, anything you want to actually do with it, like set up Wi-Fi or connect to the internet or display a video, all of those tools are written with or written using GNU tools, including a lot of microcontroller stuff. Almost all the microcontroller tool chains these days are based on GCC, the GNU compiler, which is an excellent compiler, and libc and all of the other toolchain tools that were designed under GNU. I mean, originally it was just like an editor and a compiler, and then it expanded into, you know, all these extra tools that are part of Linux.
All right, 33 years ago.
Yeah, so
And
like everything.
would you say GNU is Unix or GNU's not Unix?
Uh-oh.
Well,
Man.
GNU has become, you know, you look into the abyss. By looking at Unix, it became Unix. So now when people talk about Unix, what they really mean is
They need to rename
GNU.
it GU.
Okay.
GNU.
All right, well, happy birthday.
And there's an adorable GNU.
Yeah. Okay. Next up, open source hardware news. This is a new logo. I'm starting to show this one. Scott, you'll have to update your files one day or something. I don't know.
If I do a new run.
Yeah. So we're a supporting member of Open Source Hardware Foundation. The Open Source Hardware Summit is coming up. Tony, what are you looking forward to see? You're going to be there. What are you looking forward to seeing?
Yeah, I'll be checking out. I'm just looking forward to meeting all the people. So, like, a lot of people in the open source world are going to be there. So that'll be cool. I think there's some neat talks. I think like Micah Scott has a talk they're going to do. So yeah, I'm looking forward to just seeing what people are up to and learning about open source hardware.
Scott, you're going to be there. What are you looking forward to?
I said the Osh Park party.
Yeah, that's fun.
So
Yeah.
there's a
Everything's purple.
I think it's a public thing.
Yeah.
There's
Purple
an Osh Park
drinks.
party on
Yeah.
Thursday night before the conference, which is on Friday. And doing all the chickadee tech stuff, I did prototypes through Osh Park, and I'm a huge fan.
Yeah, we had Lane
It's
on
super cheap.
Hardware
That's how I
Hangouts.
found
Yeah.
That's how I found
Oh,
it.
wow.
I also found KiCad that way from your talk with like.
Wow, I'm glad we do these videos.
Yeah,
They helped Scott.
Yeah, I know.
it helped me.
The Scott series of videos.
Yeah. Yeah, so that's what I'm looking forward to.
Okay. All right. We're helping out Hackaday. They have the SuperCon coming up. It's in November. John Park, what are you doing there?
Oh yeah, well I just found out that I had a talk accepted, actually a workshop that I'm going to be running on creating MIDI controllers using conductive ink and microcontrollers. So
This is like, you're an expert at that now.
I just became an expert real quick to make this project, and so why not spread the love? It's a super fun. I think it'll be a lot of fun for people. We're gonna have, I think we're gonna have access to the laser cutters at Design Lab, and we'll have some CAD software that people can use so that we can sit down, learn a little bit about how MIDI controls DJ software or other music software on your computer, and then people will get to build the controllers that they want with the interface that they want.
Okay.
And you're also speaking at Maker Faire, yeah? Or
I
you're
will be
just-
Oh,
speaking
wait,
at Maker
we're
Faire.
not.
sorry,
see, there's
sorry.
a logo with Maker
But
Faire.
Phil
I
has a logo.
apologize.
Wait, yeah.
I didn't say nothing.
Yeah. Next up, tomorrow night, many of us from Adafruit in some way that happen to be in the New York area will be at the Hackaday meetup. It's tomorrow night at 6:30. So we'll see some of you there. My old job. And then Maker Faire is a Saturday and Sunday. So everyone's going to be there.
Come on out.
Yeah. What are you doing there?
I have a couple talks. I'll do a talk around noon on Saturday and noon on Sunday. I have a talk on some of my Circuit Playground projects, including the Password Vault and the scheduler and the PZ one, including probably a live demo. And I'm also going to do a talk about my Chewbacca mask, my Happy Chewbacca mask hack, how that came to be, and maybe do a little bit of circuit bending of the original brain from Chewbacca, if I can get that finished in time. It should be a lot of fun.
Okay.
Come on out.
And then all of us that are out there will be covering Maker Faire in our own eyes. So if you see posts from any of us, or videos or photos or whatever, it'll be stuff that's interesting to us, which seems to work out for Scott for some of the manufacturing things. But that's how we, like when I write for the blog, I'm usually writing because it's something I want to share with Lamore. There just happens to be a lot of people that also want to see it. So she does that too. So she'll send me something and she thinks it's for me, but there's a lot of people that like it too. So each person, like Colin's going to hit music, Noah and Pedro is going to hit 3D printing. I suspect you'll hit drones. Yeah. So there's so there's all these things, and one of the things we're going to do is we'll try to find the Adafruit stuff and like, hey, look, Adafruit, trinkets and this and that and other things. So that's what we're doing this weekend. Okay. Next up, we do this made in New York thing every week, and it's just like how it's made, but it's how it's made here. So this is the conductive paste and the squeegee that squishes it through the stenciler.
Squeeze.
Yeah, which sounds like a Batman villain, that stenciler, but it just pushes it through to the circuit board. And we used to do this by hand it was like a t-shirt, screen printing.
And then it squishes it back, yeah.
So that's pretty much it.
Good work, little stenciler
Yeah, but so
friends.
it's a friend, it's our robot friend that helps us with our work. So that's
Thanks, robot friend.
That's the stenciler. Okay, 3D printing, Noah and Pedro will be here tomorrow, but until then, here is their video this week.
Hey, what's up guys? Noah here for Adafruit. This week I got a really cool project for you. This is a 3D printed Morning Star, or better known as a mace. And the head is actually printed in transparent PLA. Why? Because inside we have a NeoPixel jewel that has 7 NeoPixel LEDs. On the outside we have composite PLA steel fill, which you can actually polish and sand down to give it this nice reflection. Inside the rod is completely hollow, and we have a wire that routes all the way to the handle, which is printed in wood filament. Inside the handle, we have an Adafruit trinket and a 2200 milliamp LiPo battery to give you plenty of time for cosplay. In the back here, we have a push button that's metal and has a red LED ring, so it looks really nice and fancy. We're gonna show you how to put together the circuit, how you can 3D print the model. It's completely modular. So let's check it out. The head of the mace is actually an icosahedron, which has 20 sides. It also features 19 spikes, which are non-lethal. To build this project, we'll need a push button, a NeoPixel jewel, a JST breakout, and an Adafruit trinket. I designed this in Fusion 360, so it's parametric, which makes it pretty easy to make adjustments. Most of the parts are hollow and will 3D print without any support material. The D20 shell is about 1mm thick. The outer shell is split in half so that they can be printed separately and glued onto the shell. The tips of the spikes are rounded so they aren't too pointy and pretty safe. A NeoPixel jewel will clip into this base, and that attaches to the bottom of the D20. The rod, handle, and pommel have threads on the end so that they can twist together, making it really easy to assemble or take apart. And that's pretty much the design. You can of course download the source and STLs, they'll be linked below. I 3D printed the handle in cork fill, which is a wood PLA composite from ColorFab, and this looks pretty cool and it has a nice feel to it. The two halves of the D20 frame was printed in stainless steel PLA from Protopasta. The pommel was printed in a silver colored PLA, but this could be any color you want. I made sure to print the D20 shell in a translucent PLA, that way the NeoPixel LEDs can be diffused. And here's all of our parts, a total of 28 pieces, so it's a pretty good amount of 3D printing, but definitely not enough to burn through a whole spool of filament. For the wiring, I repurposed this old USB cable because it's pretty long and it has all the wiring that we'll need to connect the NeoPixel. So I chopped off the connectors using a pair of snips and removed some insulation to reveal the individual wires using some wire strippers. I only need 3 wires for the NeoPixel, so we can remove one of them. The 3 wires will be for data, power, and ground. We can strip these wires and tin them by adding a bit of solder, and then we can wire them into the NeoPixel Jewel. Then I went ahead and threaded the cable through the NeoPixel holder piece and installed the NeoPixel Jewel by pressing it down until it clipped into place. Next, I threaded the cable into the cap piece and then through the rod. Now you can twist the cap onto the rod until they're fully tightened. I proceeded to thread the cable into the handle and then twisted the handle onto the rod. We'll need a bit of glue to permanently secure the NeoPixel holder to the cap. Here I'm just using super glue. And now we have our main pieces assembled. Next we can work on the push button and tin up those leads by adding some solder. We'll need some extra bits of wires to connect the button to the rest of the circuit. I'll add a wire to the positive lead of the LED on the push button. Then another pair to the negative and positive pads on the bottom of the Adafruit trinket. A bit of heat shrink tubing will make it easier to solder 2 positive connections to the common lead on the push button. Next, I can add a wire to the positive pin on the JST breakout and another to one of the ground pins. The ground connection from the trinket will go to the remaining ground pin on the JST breakout. Then the positive connection from the JST breakout will go to the normally open lead on the push button. The remaining ground connection from the JST breakout will go to the negative lead on the LED of the push button. Now we can test out the circuit by plugging in the battery to the JST breakout, and if everything's all good, our LED from the push button will light up. All that's left to wire is the 3 connections from the NeoPixel Jewel to the Adafruit trinket. So that's going to be data, power, and ground. With all of our wiring done, we'll proceed by inserting the JST breakout and trinket through the hole on the bottom of the pommel. Then we'll press the push button down until it snaps into place. Now we can do a final test, plug in the battery, and see if everything lights up. So we can fit the battery into the handle by carefully stuffing until it's all the way through, and do the same for the JST breakout and Adafruit trinket. We just gotta be careful not to rip any of our connections. So once they're in a good spot, we can then twist the pommel onto the lower part of the handle until they're tight. Okay, now we can work on the head of the mace. Here I'm using E6000 adhesive and adding a small amount to the inside of the haft. Then I'll lay the shell over the frame and firmly press them together. I'll do the same to the other half. To keep these two tightly held together, I placed a small 2.5 pound weight on top and let the adhesive cure for about an hour. Afterwards, I placed the NeoPixel holder onto the opening of the shell and inserted some machine screws. I fastened 3 of these screws and secured the shell to the rest of the assembly. The last part of the build is really easy. All we got to do now is just glue the spikes onto each of the faces on the icosahedron. I used super glue here because it dries really fast and it has a pretty good hold. And that's it. Now we have our awesome 3D printed mace with NeoPixel LEDs. That's going to be it for this one, guys. If you do want to remake this project, be sure to check out the links down below. Even if you want to make a new project, you can reuse the components to make a staff, a sword, any type of cosplay prop. Thank you guys so much for watching, and until next time, I will mace you later.
All right, welcome back. Okay,
Okay.
so No Page are going to be here tomorrow. They'll be doing 3D Hangouts and more. Before we start new products, we are supported by you, the viewer. We don't have loans or venture capital or sponsors or ads, so pick up a kit, electronics, and more, so we could take these folks out to dinner while they're here.
Okay.
So, Lady Ada, it's time.
They're hungry. It's time for new.
You want to sing All right.
Thanks, John Park.
Okay. All right, Lady Ada, what's new this
Okay.
week?
All right, so we got exciting, lots of fun little products and a couple big ones this week. Okay, let's kick it off
Yep.
with some toggle switches. So we have 2 mini toggle switches. John Park actually requested them, and I was like, yeah, good point. We should probably get toggle switches. So we did. And that was a couple months ago, and now we have them. So these are, there's 2 kinds. Well, they're both toggle, so they're on, single pole, double throw, but one of them has 2 switches in it, so it's double pole, double throw. And so these are the 2, and they're very small and compact, which I really like. And then they come, they're basically meant to be panel mounted. They come with hex nuts and these lock washers and mounting nuts and stuff. They say 6 amp, 120 volt AC, but honestly, I wouldn't use them for more than like an amp or 2 and maybe like 24, 30 volts, because I just haven't been able to test them at such high voltages, and I just don't guarantee them. So I think it's always good to, if you're using something that is high voltage, get like pretty beefy switches. These are fairly small. But yeah, so they're basically the same from this direction. It's just from this direction. One of them has 2 switches, and one of them has just 1, and that's it.
How
Toggle switches.
satisfying is the action?
They're very satisfying.
Excellent.
Very satisfying.
All right,
So
moving
toggle
right on.
switches. Yep.
We got these amazing back-to-school Arrow kits. And
Yeah,
more.
this was
Yeah.
a new products. Is worked hard with Arrow to create a set of 3 back-to-school packs, and they come with a whole bunch of stuff. So let's go to the first one, which was that one. So this one is the sort of Arduino getting started kit. So you get an Arduino Uno, and you get, I can show it on the overhead too. So you get like a genuine Arduino Uno that we even manufacture here in New York. You also get an assembled MP3 shield.
Collector's items.
Yeah,
Okay.
this is an MP3 shield that's fully assembled, so you can have it act like a MIDI device, or you can have it play music, and it has a headphone jack, so you can make a little music player. I thought this is kind of the most fun standalone shield that was like, you could get started and do some very interesting projects with it, especially since the Uno can do sensing and stuff. You get an SD card that is pre-flashed with MP3s of Frequency, which is the album that we play a lot of our background music effects with. You get a USB cable, standard type, and you get some powered speakers. So these are some speakers that you can plug into USB, so you can even make loud music with your Arduino kit. So this is the first kit that we came up with. So it's getting started with Arduino, and it's like we wanted to do something that wasn't just like you get a bunch of parts and a breadboard. You actually snap it together and you make a project.
All right, next up.
Okay, so the next one is the Learn to Solder pack, and this one I think we have a photo of all the things.
Yeah, everything.
So this is really this is a pretty neat kit, because this is really everything you need to get a lot of experience with soldering. You get a lot of extra parts as well. So you get a soldering iron, you get a really good one, plugs into the wall, and you get a really nice solder stand to go with it, so like it won't roll around your desk. You also get a roll of solder, some really high quality solder that we sell. And diagonal cutters, which is essential for cutting leads after you've placed them. And then you get 3 kits. You get a mini PUV 4, which is a Precision Vision RGB LED display, which is really fun. You get to build your own Arduino by soldering headers onto a Metro. So you even get an Arduino at the end of this one as well. And then you also build a Minty Boost, which is our most popular kit. So you can build your own AA phone or gadget or PSP or whatever charger. So this is sort of like everything you need to build 3 kits, and then of course you get really good high quality tools that will last you a lifetime.
Okay.
Okay, and then
last
the
up.
third pack is an Internet of Things pack. This is the most advanced kit, and this one is neat and interesting if you're interested in doing Internet of Things and sensing, and you want to explore our Feather line. So this board, can you go to the next photo? Because there's so much stuff in it, I can't remember all of it. Okay, so you get a Feather ESP8266, which is our most popular Feather. It's an Arduino compatible Wi-Fi microcontroller, and then under me is an OLED feather wing, so it's a plug on top that adds an OLED display and 3 buttons. You also get a fun group of sensors such as a door switch sensor, it's like a magnetic sensor, a PIR sensor that can detect people as they move around, so you can like build an alarm system, a servo, so you can have things move around, and a temperature and humidity sensor, that's the little white thing at the bottom there, and a micro USB cable as well. And then we also give you a parts pal, which comes with cables and headers and parts and LEDs and a breadboard. It's like a super fun pack of like all sorts of, I think like 80 or 90 different components that are really handy, that go well with all of this stuff, and will let you kind of build any Internet of Things projects that you're interested in. We have tutorials as well for using Adafruit I/O with this board.
Okay, next up. You made this.
Okay, so the unique product for this week from Adafruit is the Max 31856. This is a universal thermocouple amplifier, and their most popular breakout, I think, is the Max 31855, and that is a K-type thermocouple amplifier. So if you're doing anything with high temperature and you want to measure temperature at a remote location, you use a thermocouple. They can go up to like 1,000 degrees C or more. I mean, they're extremely high temperature probes, like often used in kilns, people who are doing beer brewing, people who are doing coffee roasting, like John Park, who I'm sure you built your own coffee roaster. If you're doing all sorts of like science experiments or glass work or whatever you want to do, like barbecue smoking, people use thermocouple, very, very common. And so our K-type thermocouple amplifier only did K-type thermocouples, and depending on the metals in the thermocouple, they have different names like J, T, Q, whatever. And K is the most common, but it isn't the only one. Sometimes people have J-type or N-type or T-type. And so this thermocouple amplifier can do K-type, they can do all of them. So it's a much more universal amplifier because it can handle, I think as far as I can tell, every thermocouple type there is. So it's just basically an upgrade for people who are like, oh, well, I want you to have like a J-type amplifier. Well, this one does them all. And in the firmware, when you upload it to your Arduino or compatible microcontroller, you tell it what thermocouple you have attached, and it does all the amplification and noise cancellation and linearization, and it just pops you back a temperature in like 0.1 degrees Celsius precision. And it's like a really great, easy to use amplifier. So I think this will be pretty popular for people who are using something not just a K-type thermocouple, but other types. But it can do K-type as well. So now you have a choice.
Okay, and big announcement, we are now, I think, the only US distributor, reseller, besides like Toys R Us, of the Kano kits.
Yeah, so there's 2 Kano kits. Okay, so can you skip forward?
Yeah.
We'll do the computer kit first.
You want to do the computer?
So the first kit is, no, keep going.
Yeah.
That one. Nope, next one.
You want to go here?
There you go. So the Kano kit is a DIY computer kit built on the Raspberry Pi 3, which is great because it has built-in Wi-Fi and Bluetooth. And it's a little, you get an enclosure and a speaker and a keyboard with a little tablet mouse on it, a touchpad mouse. You get an HDMI cable, micro USB cable, and a booklet that takes you step by step through how to install the operating system and run it, and you turn it on, and you basically get kind of a simplified desktop experience where this is like your first computer and you built it yourself. So I thought that was kind of neat. You get a bunch of stickers and this booklet and all these parts, and it's a fun experience. And then in addition to that, there is also the screen that they made, so you can make your own TFT screen. It has an HDMI decoder, and you build it, and it's kind of interesting too. So it's a nice 10-inch diagonal IPS display, and then on the back you can kind of mount both the TFT driver on the left there, the control board up on the top, and then to the right is the Kano computer. But it's a Raspberry Pi. I mean, you can still run Raspbian on it or Noobs if you want, but their operating system they wrote, I think it kind of simplifies a lot of the process for people, and I think that's what you're really getting here. It's not just the Pi, because you can just buy a Raspberry Pi and a keyboard and mouse, but what you're getting is this really easy experience when you turn it on, and it's pretty much ready to go, and the SD card is pre-burned and everything. So I think it's interesting, and yeah, I see people using it and really liking it. So I think, especially as a gift, this is pretty common. people get this as a gift for their kids.
Yeah, if I remember, my daughter and I played around with this at one point, and it takes you on kind of a guided tour through learning different parts of the thing, so it almost gamifies.
Yeah, you have like a book.
Yep.
I haven't, we just got these today, so I haven't even put one together. We have one we put together just to make sure it worked, but we haven't looked at the booklet. But I think the book is kind of also the strength of it. Like you get activities, and they have like a
stickers.
form and stickers.
The most adorable keyboard in the world.
And the super cute keyboard does like, it's like, hey, take it around, it's a wireless keyboard. And then online, I think they have activities and a full experience. And so this is something that you would build on, and I think they'll probably release more projects and software and updates.
Okay. It's never been a better time to be a kid. All
Yeah,
right, and
this
with
is
that
fun.
is new products. Thank you,
Okay,
Lady Ada.
thank you.
Zoom. Okay. Well, everyone, if you're going to buy something, save a buck or two.
Okay.
Use the code. And we're going to do, it's not out yet, don't ask, because there is something special tonight.
Oh, you know what?
Yeah.
Yeah, sorry, I
I know,
forgot.
she's back. She's back.
I'm back. Sorry.
This is why we have these graphics.
I
No one
know.
knows anything that's going on.
We don't
behind
usually
the
have
scenes.
it out yet. when
So
we
it's not out yet. Don't ask. This is going to be delightful for some and terrifying for
Yay.
others.
No.
Out yet?
Yeah, this is.
It's not out yet. Don't ask.
Yeah, so this is from Eagle.
Yeah,
who
so I
did
have
it.
this. Can you go to the overhead?
Oh, you mean it's real too?
No, it's real.
Oh.
Yeah, you asked me to send the Eagle Cat. So this
Oh.
is, so we made the Metro, which is our Arduino compatible using that Mega 328. So it's like an Arduino Uno compatible. And then for a while, actually, I've been sitting on this version that uses the SAMD21, which is again that kind of high-powered, high-octane chip that is in the Arduino Zero. And we're thinking that this might be a good platform for, basically you have the Arduino-like experience of having shields and a breadboard and plugging wires in, but it runs MicroPython. So this has an ATSAMD21 over here and all the supporting circuitry, the micro USB connector and power, and the LEDs over here like the other Metro we made. But then we added some SPI flash. So the idea is that, one of the things we came across is no matter how much space you have, you always need more space. And so having SPI flash on it means that we might be able to have a kind of a basic file system where you drag modules onto it, and then you can call that code in when you need it. Just because with an interpreted language, you don't compile a library in when you run your sketch or your Python code. You actually have to have that pre-compiled ahead of time, which is, again, the trade-off with MicroPython. But so it'll be really interesting to see. We're going to try to get this SPI flash working. This is 2 megabytes, but you can get up to 16 megabytes of SPI flash for 40 cents. So it's pretty cheap. And then there's, of course, SWD debug if you want. But other than that, this should be able to work with all of our Arduino shields as well. But you'd
Okay.
be programming it in MicroPython.
All right, I'm not going to ask you anything about it.
Don't ask anything.
Okay.
It's not out yet.
All right. Yeah. Okay.
All right. Now I'm scooting.
All right, and that was a top secret. Back in the vault,
Yeah.
secret thing. Okay. All right. Well, we're gonna do some questions. If you'll
Okay.
have for a little bit. We'll run a couple of minutes over. We have guests. We always do that. The first one, and we'll have assistants here. Someone wanted to see this, what it looks like in human hands. John, can you want to do the honors? You have at least 2 human hands.
That's the requirement.
Yeah.
On the overhead.
Yeah, the overhead. This is what it looks like. Yeah, human hands.
Giant hands.
Yeah. Like it is. Lift it up a little bit so you can see. Yeah.
It's definitely for kids.
Yeah.
But for kids, it's
But that's
great.
not so bad.
No, it's not too bad.
Okay.
Very compact.
Orange.
That color. God, I love that color.
It's cute.
Okay.
You're like an orange fan? There's some
Thank
people
you.
who love orange.
I really do.
Okay.
Yeah. I'm not wearing any.
Thank you, human hands. Okay. This one is for John. When will the PZ1 stencil be available?
The PZ1 stencil is available. If you go to the learning guide, you will see a download of an SVG file, and you can take that, print it out, and transfer it and cut it by hand if you want to with an X-Acto. You can laser cut it. I think you could probably mill it. There's probably a few other ways you could use that file, but it is available now.
Okay, whoever wants to grab this one can say they want to grab it. I'm trying to find out if Circuit Playground has a pin 11 accessible for SD card interfacing. Who wants it?
I mean, you can bit bang it, but I don't think SPI is accessible because it's being used for the accelerometer. Yeah, so you don't really have access to the SPI pins. The Flora has them available, but not the Circuit Playground.
Okay. I think this one's for Scott. How many drummers has Lamolo gone through? What is this?
It's his band on his shirt.
Oh, okay.
Yeah, so that's funny. The band Lamolo is a band out of Seattle. You should look them up. They're awesome.
Okay.
And they are on, as far as I know, their third drummer.
Okay.
Okay.
Megan's the lead singer, and she does a lot of the work and writes most of the songs. So she hires a drummer.
Is this a Spinal Tap situation? Do the drummers just die?
No, they do not.
good.
No, they're still living. At least the second drummer was also in another pretty popular band, I think. So part of that.
Okay. Of course, the usual question that comes up that I'd already predicted. We'll start with you. Scott's to have the microphone. Favorite programming language?
Favorite programming language? Yeah. Well, yeah, we talked about this earlier. My answer was C++ 11, not C++ in general. So my background is I spent almost 6 years at Google, and I did C++ in that whole time. And a lot of the stuff that was introduced in C++ 11, we also had prior to that. So I think C++ has gotten really, really awesome. Python's a close second to that, I would say.
Okay.
It's just so easy.
Tony D? Which one?
I'm going to go a little bit different. Last time I said Python, I'm going to go with Scheme. And Lamar, you might back me up on this. Like, it is a great
MIT
language.
changed to Python.
Oh,
Yeah, they did. Yeah, it's true.
So Structure and Interpretation of Computer Programs, SICP, look it up, great book. The original one, I guess, the Python version. But Scheme, cool language. Even like young people can pick it up. It's good.
Okay. John?
I'll go way off in left field and say the Mel scripting language for Maya, since I used it for so many years in animation and visual effects. It's sort of C-like. I think it actually had its origins in Tickle.
Wow.
And it's not far of a stretch for me, having then moved over to more Arduino stuff coming from Mel. So I like Mel.
Okay. All right.
cool.
Well, those are the guests.
Yeah.
Yeah. All right. Next up, anyone can grab this one. Dear Adafruit, is it worth trying to get FFT code running on an 8 megahertz 32U4 or a Feather M0? Thanks.
We have an example. The Piccolo has example code for FFT with like 16 or 32 bins.
Okay.
So you can just grab that.
Yeah, if you want more bins, you probably want a faster processor. And if you get the Teensy, that has a hardware accelerated FFT, the Teensy 3.2, the M4, Cortex M4. So
Someone said, good move going from Google to Adafruit. That's cool. Good for Scott there. Next up, what advice would you give someone trying to make a ARM-based single board computer, Atmel or TI?
TI has good documentation. So like the, the OMAP processor, I want to say. So that's potentially a good thing in their favor.
Okay. Next up, whoever wants to take this one, what would you pair with a thermocouple amplifier to build a single data logger with multiple thermocouples?
You want to answer that?
Wait, what was the question again?
Yeah,
Sorry. I know. I'm zoning out here.
Yeah.
So.
What would you pair with a thermocouple amplifier to build a single data logger with multiple thermocouples?
Well, so I have a library for the Raspberry Pi for the Max 31855. So not this one, unfortunately. But that could be a good option if you have a Raspberry Pi, because then you can save it, you can upload it somewhere, write Python scripts for it. So check that out. That's what I would do. It'd be easy.
Okay. Tony fan club's here. Tony looking sharp. So
Thank you. Yeah, this is a circuit board tie and shirt. So.
All right. Let's see. Okay, I got through. Oh, this is for John Park, but anyone else can answer. How much time does it take for the? Oh, how long does the ink stay on the cardboard conductive? Sorry.
It has not degraded, other than you can rub it after a while. It's water soluble, so you see it starts to rub away. It's still effective. And not on this one, but on another one, I got some Mod Podge and basically, whoa, there it goes. Yeah. Basically sealed it, and it maintains its capacitive sense because it doesn't require direct touch. So you can put like a fixative on it to protect it.
Mm-hmm.
Okay, so speed round stuff. Tony and Scott can shout these out. What functions does regular Python have not included in MicroPython?
Oh boy, some of the like meta class stuff isn't there, but almost all the Python 3 core language, not 2.0. So look at 3, but there's not a lot of differences there. So
Scott, do you
You
ready?
There's a lot, I'm sure. If you find something and you need it, file an issue on our GitHub, and maybe we'll get to it.
I think exceptions are a little bit different, right? The way the exception it's not a true class.
It's similar,
Is it?
I believe. I think exceptions are still okay, but yeah, there is some stuff that's more advanced stuff. Like 90% of Python is there. So
yeah.
Okay, John Park, what video are you working on next?
Oh, I've got some Halloween projects I'm going to work on, and one is going to be sort of a spooky decoration that involves UV lighting and the glowing quinine and tonic water. And then I think I'm also going to do some props that are interactive, lighted, and motion sensing, maybe some sound. Probably those will be with Circuit Playground. I think the UV lighting project will be one of the feather boards. So those are the next two I've got
Okay.
in the hopper.
Please let us know what timing on the MicroPython implementation for M0. What is that?
2 microseconds.
By timing, I assume they mean when they have it available.
Yeah.
And I would say check out the GitHub repository. It's github/Adafruit/MicroPython is where we're doing all the work, and as I do the work, it goes straight there.
Yeah, and then pretty soon I just made a little Vagrant-based virtual machine to build the firmware. So look for some guides in the next couple weeks on getting started with it. It's going to be beta, so it's not totally like bulletproof yet, but we'll have it out soon.
Yeah, file an issue.
Okay. And that is it. We're all
Okay.
through. We're through all three.
Yay.
Whew. Okay. Well, thank you, everyone. Those are the questions.
Tony, do you want to demo the it's not out yet thing? I don't know if did we get to demo it yet, or is it? Yeah.
Okay, so I'll show off real fast what we showed on Show and Tell.
On the
So
overhead?
Yeah, just because the overhead,
okay,
you'll
yeah,
actually
yeah.
get to see it.
Should I put the shield back on it?
Do your magic here.
okay, so this is basically the SAMD21 based Metro. So that's the board. It can run MicroPython. This one is running MicroPython actually, so Scott's code. And then I just added the NeoPixel code earlier today, so that this is the Arduino NeoPixel shield, and we plug it in, and then it just has one of the digital pins connects to the NeoPixel signal line, and it's going to light up all the pixels using the rainbow animation. The cool thing too, shout out to Phil B, the master of the NeoPixel. We basically took his NeoPixel code for the SAMD21 and works pretty much out of the box on MicroPython. So that's the cool thing also with MicroPython. You can add C functions, and so there's a C function that's doing the actual NeoPixel lighting kind of routines.
Leave it on because we're going to be doing stuff soon. So
If you hit this button,
Which one? What button?
this one, it will.
Yeah. That's a little.
There you go. So there's some rainbow. So that's rainbow cycle.
does actually work.
And it's all Python code that's controlling that as far as like figuring out which colors to light. There's just a little bit of C code that does the little timing stuff that's kind of critical for that.
Okay, we're going to give something away, and then we're going to have
Rainbow
DJ.
party. I know we're getting the rave started here with some lighting.
So, Lady,
beatboxing.
what are the
Hey.
rules of the trivia contest?
Rules are you can only enter once per lifetime. Anyone who answers the question the way Phil wants to see it in the chat wins the fabulous prize. And the prize tonight is going to be a Max 31856 breakout for thermocouples.
Okay.
Wow,
So if
handy.
you win, the PID is 3263.
Yeah.
All right, ready?
Yes.
Here's the question. Which school was Stallman working at when he developed the GNU operating system? Which school? Where? Where was he? It's not 42. It always says that. Pool lights? No. It's not a school.
I think that was before you asked the question.
Rainbow Party. Oh. DDW Smith, congratulations in the Twitch chat. You won. He was at MIT and then he quit, so MIT couldn't own it. He was in the lab. He's like, I got to get out of here. 'cause he wanted
And
to
they
make sure-
changed from Scheme to Python. I'm just saying, it's been downhill. Downhill.
That's uphill.
So,
I did some skiing.
School of Hard Knocks was almost close. So, all right. So that's the trivia question. DDW Smith, email support@adafruit.com and tell them you won PID 3263 to thermocouple. And now it's time for sprockets when we dance, and let's start DJing or having John Park DJ. We have the microphone. Yeah. That's the show for the week, folks. I'm gonna hit the lights. Let's see what happens.
Oh, I need to make some awesome noise.
I told you it's small.
Oh, yeah.
Okay.
Yeah, there we go. Is that better?
Okay.
All right, and that's the show for
Thanks,
tonight,
everybody.
folks. Don't forget, the code is Make It Fair New York. That gets you 10% off all the way up to 11:59 p.m. Eastern Time tonight. Thank you, special guests here. We're in midnight mode. John Park, Tony Nicola, Scott, Lady Ada, all our remote people out there, and all of our folks here at Adafruit. Thank you so much. We'll see you next week. Here's a picture of a cat. Gotta do
Night,
that.
everybody.
And here is your moment of Zener.